Hey there, here's section 3.3. We're going to still be graphing inequalities, but we're going to be looking at systems. Now, I wanted to show you that you've already learned what systems are. You did this in Math 1, and so I Googled systems. Let's just do system of equations. This is where you graph two equations on the same line. Okay, and so if I change this to graphing a system of inequalities, we'll do linear inequalities. Okay, so you draw them, like if you're given y is greater than negative 3x plus 5, it'd be a dotted line. You would shade above it. And then y is less than or equal to x minus 2, be a solid line. You'd shade below it, and the common shading is right here. So this is all Math 1 material, but shading, I know these are blurry. Let's see. Yeah, so you've learned this. You graph both of them and you find the common shading, and that's your answer, okay? So what we're going to be doing today is looking at quadratics with the same principle. So it should go pretty quick, but you never know. All right, so section 3.3, essential questions. How do you graph quadratic inequalities? These first few are the same as last essential questions. But if we go down to the orange one, how do you decide where the final shading belongs? That's the kicker. This is that same little purple thing that I showed you in the last set of notes. But here's our first note card 80. Steps for graphing a system of inequalities. You need to write this stuff down. Step 1, graph each equation with identifiable information, intercepts, vertices, dotted or solid lines. Take note of where each inequality would be shaded individually. Darkly shade the common shading and then test a point. So pause me and finish up note card 80. Now, I'm going to do something a little different and not identify what note card numbers are yet until the end of the recording. So I just want you to pay attention right now. I don't want you to worry about writing anything down. I want you to take a look at these. And yesterday's lesson, I had you really be meticulous and graph these things by hand and all of that. And I'm still going to have you do that. But yesterday I had you find the vertex by hand, all of that. I'm going to let you use Desmos to get the identifiable information. So right here in this note card where I said identifiable information, intercepts and vertices, you can get all of that, the corresponding points, all of that, from Desmos today. So look at this. This is a quadratic. It's a vertical stretch by 2. It's gone left 5 and down 7. That one was in vertex form, so that was easy to say. This one is in standard form. Let's see, it opens down. Oh, this top one opens up. This one opens down. The y-intercept is 5. Vertical shrink of 1/3. So I'm going to take this away, and there it is. That's plopping it in, and looking at it, you'll see that this one that was greater than or equal to is opening up, so that's a solid line, and it's shaded above. And this one was a less than, so it's a dotted and it's shaded below. And the common shading that you need to shade really darkly would be in between these two. Now, when we go to do this by hand or sketch it with our own hand, we need to make sure we have the vertex labeled and all of that, okay? All right, so this one, oh, wait, it's the same one. Okay, now let's look at this one. You've got two quadratics again. This one, if I distribute that out, would be a quadratic. It's opening down. It's a vertical shrink by 1/4. It's solid, shaded below. This one is in vertex form, so it's opening down, vertical shrink by a factor of 1/6, left 7, up 3. Okay, what would they look like? They're both opening down. So this top one has a less than or equal to, so that one, when we graph it, would be a solid line and it's shaded below. This one right here would be a dotted line and it's shaded below, and our common shading is right here. That common shading is not bounded. It would keep going on and on and on down here. Now this other one I showed you, this common shading is bounded. All right, so let's think about this one. If I were to graph this, this is what it would look like. And this top one is shaded above. There we go. This bottom one is shaded below. So where is the common shading? What would the answer be? It would actually be no solution. Remember, you can use that symbol that has the circle with the line through it for no solution. That can happen. That absolutely can happen. All right, so now let's look at this one. We've got y is greater than or equal to x squared, and y is less than or equal to negative x squared plus 2x plus 4. All right, so let's look here. You would graph both of them. This one just has more steps written out for you, but they're both solid lines. This one, y greater than or equal to x squared, is this bluish purple color. We would shade above it. And then this one is this reddish color, and we would shade below it. And the common shading is that pink area. Now, I didn't talk through this last step that you have on note card 80 yet, where you test a point in the common shading to make sure that it works at each inequality. So let's look at this one. So in the common shading, a test point here, they picked 1, 0. It doesn't work in number 1 and it works in number 2. I don't like that test point. What is a point that would be in both of these? It'd be 0, 2 would be a point that would be in both of those. So 0, 2. 2 is greater than or equal to 0? Yes. 0, 2 is the point I'm using right here. 2 is less than or equal to 4? Yes. So when I say test a point, let's look at this one. Okay, so what is an ordered pair that's in this common shading that we think is the answer? Let's see. I gotta use my finger. Negative 4, 0, right here, negative 4, 0. So if I want to plug that in, I would put negative 4 here and 0 here. So that'd be 5 squared is 25, 50 minus 7 is 43. Is 0 greater than or equal to, wait, what did we say we put there? Oh, the y value was 0, and the x value was negative 4. Oh my goodness. Oh my goodness, y'all. I'm picking the point. Negative 4, 0. I need to write that down here because I totally forgot what I was doing. So my test point is negative 4, 0. All right, so I'd plug in here. So it would be, is 0 greater than or equal to, I'm plugging a negative 4 in. So 2 parentheses negative 4 plus 5 squared minus 7. Let's see. Let's see. This is how you test it. And it's a tedious process, but it's how you can know if you're right or not. So is 0 greater than or equal to, all right, that'd be 2 times 1 squared, which would be 1, minus 7. So is 0, and I know I'm being all messy right now, is 0 greater than or equal to negative 5? It is. So it satisfies in the first inequality for sure. Now I need to go and see if it does in the second one. Is 0 less than, oh gosh, we got to plug in a negative 4. So I have negative 1/3 times negative 4 squared minus 2 times negative 4 plus 5. And you know what? Oops, I put 54. I'm going to get my calculator and type negative 1/3 parentheses negative 4 parentheses squared minus 2 times negative 4 plus 5. Yes, I just used the calculator and I got 7.6 repeated. So is 0 less than 7.6 repeated? Yes. So it satisfies both of the inequalities, so our shaded region is good. That's what it means by using a test point. Okay? All right, so here's note card 81. It's an example of graphing a system of quadratic inequalities. There are the quadratic inequalities that I've typed in there for you. And I want to work through these with you and what will be expected of you to do on your own sheet of paper. Now, you can go and find the vertex of each of these and find the corresponding points of each of these the way I went over in section 3.2. I am okay with you at this point going to Desmos and typing them in. Now I'm going to type them in without any shading right now, and I'm going to do them one at a time so I don't get confused. All right, so I have this one, and I've got my piece of paper where I've written this down, and I'm going to write down that the vertex for this one is 0, 4, it's opening down, and A is -1, so I know I'm going to have the point 1, -3, and the point, I'm sorry, that was the point -1, -3. I can't get it right there, but you know what I mean. -1, -3, and I keep saying that wrong. -1, 3, and 1, 3. Okay, so I'm gonna write those down on my own sheet of paper. Do you ever just get on your own nerves? Like, I get on my own nerves so often. So -1, 3 is one of my corresponding points, and my other one is 1, 3. I think I said it right this time. And this one would be back to here. This one would be a solid line, and we would shade below. So I want to show you with the document camera my thought process on this one. Okay, so that's what I just did. I just worked on this one right here and got everything that I needed. My vertex, my corresponding points, and it's solid, a solid line, and it's going to be shaded below. Now I'm going to go do the same thing for this one. Okay, so here it is, and I'm going to be writing some stuff down. Let's see, I've got the vertex is 1, -4, and my corresponding points are going to be 0, -3, and 2, -3, because A is 1, so we're going to go up 1, left 1, and up 1, right 1. And there we go. All right. So we go back over here. All right, so I've got the vertex, the corresponding points. This one's going to be a dotted line because it doesn't have the equal to on it. And we're going to shade above. So all of that is important. All of that I'm going to need on my own piece of paper. Now again, you can use something like this. If you want to print off some little graphs, you can, or you can use graph paper. I'm actually going to do that this time. This document camera is okay. Scroll out just a little bit. I said scroll out. Zoom out. Okay. Alrighty. So, excuse me. All right. So I'm going to do the first one. I'm going to go to the point 0.4. Okay, I've got that from right here. Check. All right, and then -1, 3, and 1, 3. Check, check. And it's solid, and I would shade below. But guys, I am not going to worry about shading yet, because remember, in the prior note card, I said wait on that. Now, I do know that the x-intercepts are -2 and 2. That's good to know. Make sure you draw it, especially when you're drawing two quadratics, you need those intercepts. I could have shown you that on Desmos. I just didn't show you that, but just get the intercepts from Desmos. And I just do the best I can. I don't want to make it a V. It is a U. It's upside down U. All right, now I'm going to go back while I have this one still pulled up and get my x-intercepts for this one. I'm going to write them down. So my x-intercepts. You can't see what I'm writing, but you will be able to see in a minute. Are -1 and 3. Okay. So I went ahead and added that right here as a set, because remember, those are the solutions. So a set of the solutions. So now, looking at this other one, my vertex is 1, -4. And I'm like, oh no, I should have extended this down lower. So I'm going to just take that first one and extend it down lower. Okay, now I've got an x-intercept at -1. I have an x-intercept at 3. So visualizing this one, it's going to be like that. And I'm going to go and do my corresponding points. 0, -3, that's a y-intercept. We need that anyway. And 2, -3. It's dotted. There we go. Okay, I'm going to zoom in a little bit. All right, so there we go. And I'm not going to make you label all the little points because you've got them all written down up here. If you do that, then you're going to be good to go if you have all of that information written down. Now, Remember, the first one that we drew that was solid, we shade below. And the second one that we drew that was dotted, we shade above. So our solid one, we would shade below. That would be all of that. And then our dotted one, we would shade above. So where is our common shading? Our common shading is right here. I have some students that just would rather wait and not shade at all. Like I did a really light shading there and looked where it was the same. And they'd rather just wait and then just shade at the end, and that's great. So that is the answer. And so when you write something like this on your paper or right now on your note card, you need to have all this information. You need your intercepts, which I need to write them out right here. For the first one, they were -2 and 2. Okay. And this was already, the vertex was my y-intercept, so we were good to go on that one. So you need your intercepts, you need your vertex, corresponding point, where it's shaded, and what the line is, if it's solid or dotted, and all of that. And then you've got everything you need. Just make sure you don't forget to do the common shading. All right, so I just took an image of what I just did with you and plopped it on here. I can't tell if that's going to be there. Hold on a minute. That little plus there. I wish it would go away. But anyway, that comes from the document camera. All right, so I know that was crazy and wild, but we're going to do one more. Okay, so pause me and go ahead and finish up this note card. Okay, so I did want to go on to Desmos and show you that, of course, you can type them in, and I know I've been saying that, but you could put them on there together with the inequalities and all of that. There's the first one, and then okay, and then there's the second one, and I'm trying to look at my graph. Oh, that can't be it. Oh, it's a -3. Okay, because I did not match what we just did together. Okay, so this isn't all kind of smushed together, and I'm just going to spot check some of our points here. 1, -4, 3, 0. Yeah, I mean, we're good. And we can see that the final shading would be right here. So I just wanted you to see that. Just did, yeah. Y'all enjoyed that, right? I composed that just for you. All right, so we are on to our last note card 82. Another example. Here we go. Both of these are greater than. One's got an equal to on it, so this top one's going to be solid. And I'm going to go ahead and write these things down. So this is solid. It is going to be shaded above. Opens down. How do I know it opens down? It opens down because it has a negative in the front. This one is going to be, oh goodness, dotted. It's going to be shaded above as well because it's a greater than, and it's going to open down as well. Okay, so I plopped these into Desmos. And we got craziness happening here. We got some craziness happening. So on your piece of paper, on your note card, we need to get some key information. So this is the red one. Oh, there we go. I'm going to undo the blue one. Okay, so here's the red one. I don't know if you saw what I did over here, but if I want it back on there, I just click that circle on the front. All right, so here's the top one. And I'm going to, on my note card, on my piece of paper, I'm going to write this information down. The vertex is 2, 4. The x-intercepts are 0, right here, 0 and 4. And you know what? I'm just going to use those as my corresponding points. That works, okay? And then on the blue line, the vertex is 0, 0. And I need to find some key points. This will work, the -1, because you know A is -1. So, oh goodness, -1, -1. Oh, of course, my pencil lead just broke. And then right here would be 1, -1. Okay. Now this one does cross the, well, actually the vertex is the x and the y-intercept, so we're good to go there. All right, so I'm going to select both of these back on here, and I see craziness happening, and I'm going to figure out where to shade and all of that. Okay. So again, this is solid line and above, the first one is, and this one's going to be a dotted line and above as well. So I get all of that, and I have Desmos, and it's wonderful, but I need to be able to graph these on my own, okay? So the last time I used one of these, and I'm going to do that again. And I will link out to a template of these if you want to print them, but you definitely don't have to. Oh, you see that? Oh, my goodness, what's happening? Okay, so for this first one, I'm going to go to the vertex of 2, 4. Okay. And then my x-intercepts were 0 and 4. And that's what I need for the first one. It is solid. I'm not going to shade yet. So that's the first one. The second one, the vertex is 0, 0. Okay. And then my corresponding points were -1, -1, and 1, -1. And it's dotted. And right in here, I'm going to want to look at Desmos because I need to extend this on down. Just so I can, yeah, that makes me feel better. And I'm just going to look at Desmos just to make sure. Yeah, okay, so we're good to go. All right, so back over here. The first one that I did, it was solid, but we need to shade above. So we would shade like this, shade above. And I'm just looking at that first one. Now the second one I did, it's dotted, and here it is dotted, and we also shade above. So it would be like this, shading above here. So where is my common shading? That's a hot mess. So how do I figure out what the common shading is? Okay, so to get the common shading, we know that they are both above. And so I'm going to unclick this so you know you're above that. And then I know I'm above that. So where am I above in both? It's this darker purpley color, okay? So it's above both of them. It's got to be above both. So back here, when I go to actually do my final answer, the final shading is going to be, okay, now I'm going to be careful here. Like that, okay? So it cannot be in here, it cannot be in here or in here, and that's the answer. Good job, guys. I'm going to take a picture of this and get this back on the slide, so hold on. No, the picture didn't show. Hold on. All right, so I think I have all that on here now. What a way to get through a 23-minute video. I hope it makes sense. I know some of you be like, Ms. Sharp, why can't we just use Desmos? Guys, Desmos is a great tool. It is, but you still have to know how to do this stuff. You still have to know how to get the key information and how to plot it, like old school stuff. You still have to know how to do that. So thank you for being patient with me. Make sure that you're doing your homework nice and neat. Okay? Bye, guys.